Welcome to lesson 4.1. We're going to be comparing linear functions and exponential functions today. Now, first let's look at a linear function. This is the one that we have been doing, and that comes in the form of y equals mx plus b, or f of x equals mx plus b, and this is what we've been exploring a lot of, straight lines. All right. So if you see here, 2x plus 3, that's our m, that's our b. We've learned this all before. That's our slope, and that's our y-intercept. And this, when we graph it, will be a straight line. All right, we're going to get a straight line when we graph it. All right, and this is called a linear function. Linear. See that key word there? Line. That's the key word. All right. Now, if you look at the table of values, if you put this function into your calculator, what you should see is, let's see, at 1 you should see 5, at 2 you should see 7, at 3 you should see 9, at 4 you should see 11, at 5 you should see 13, and 6 you should see 15. And if you notice here, when you look at this table, it always goes up by the same amount. See, it's always going up by 2, right? Every time it goes up by 2, and up by 2. The reason I know that this is a linear function is because it has a constant rate of growth. Okay? The rate that it grows at stays the same. That's another way of saying it. So you see how it goes up by 2 every time? The constant rate of growth. The growth stays the same every time. It always goes up by 2. So just looking at this table, I know it's a line because it has a constant rate of growth. So if someone asked you, why is this, looking at a table, how do you know it's a line? It's because it is a constant rate of growth. Let's try graphing this guy. Well, at 1 we have 5, at 2 we have 7, at 3 we have 9, and it looks like that's all we can graph. We draw our nice little line here, and of course that looks like a nice straight line. All right, this is y equals 2x plus 3. All right, straight line. Now if you look at the graph here, it also has a constant rate of growth. It always goes up by the same amount. It always goes up 2 over 1, 1, 2 over 1, goes up 2 over 1, right? So it has the same rate of growth. See, that's plus 2. That's also up 2 plus 1. So it also has a constant rate of growth. So what do we know about lines? They have a constant rate of growth. Now let's look at exponentials, all right? This is an exponential equation. How do we know it? The key to knowing that it has an exponential equation is that it has this. It has a variable as an exponent. You see that? The x is an exponent here, and that makes it an exponential function. See how these two are connected? If it has a variable as an exponent, it is an exponential function. Now let's see what that looks like in a table. Let's plug in these values. When I plug in 1, put this in the calculator, see what you get. See if you can fill this out, pause the video. Well, if you put in 1, you get 2. If you put in 2, you get 4. If you put in 3, you get 8. If you put 4, you get 16. If you put in 5, you get 32. And you put in 6, you get 64. Now let's look at this. Let's look at this table. Let's see how this grows. Well, first it goes plus 2. But then it goes up by 4. And then it goes up by 8. And then it goes up by 16. And then it goes up by 32. So if you see here, unlike this, our line, where it always goes up by the same amount, the rate of growth is increasing. So what we would say here is an exponential function has an increasing rate of growth. See that? It goes up by more every time. It goes up 2, then it goes up 4, then it goes up 8, and then it goes up 16. When you have a growth rate that's not consistent, all right, then you know it is an exponential because it's not going, it just keeps growing and growing and growing. That it has an increasing rate of growth. So someone said, how do you know, looking at this table, it is a exponential function? It has an increasing rate of growth. No, let's try to graph this. Well, at 0 it's actually 1. I know it's on the table, but 0 it's 1. Look at your table. At 1 it's 2. At 3 it's, at 2 it's 4. And at 3 it's 8. And what you should get when you graph an exponential is something that looks like this. This kind of curved line here. And this is y equals 2x, 2 to the x. All right, and that's what an exponential looks like. So if you ever see a graph that curves up and goes up, 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 that is an exponential. All right, turn to the other second page and see if you can answer those problems.